Hello, hi. Hello, everybody. This is Thacienne. I am here and I'm happy to be here. Welcome to Thacienne's class. Today, we are doing something different, a bit different from what we have been doing. For those who have been following, we have been doing some tutorials about programming using our studio, but now I have been thinking about something different. Guess what? As you can read here, it is written NESA. Who knows NESA? NESA. Who knows NESA? Type it in the comment. National Examination and School Inspection Authority. But guess in which country? I know that you are watching from different countries, but in which country this NESA is from? My motherland is calling. Rwanda is calling. And I'm saying, here I am. I have been thinking about contributing to the education of students in high school level. And I hope if I make some solutions of national examinations, past exams of national examinations, and make them available for everybody to watch, and it will be a great contribution. So I hope you will enjoy this kind of content. I will not be giving this type of content every day, but I will make sure to solve all the examinations, mostly for senior 6 level examinations in mathematics. Today, people in ANP have been blessed because I'm starting with their examination. ANP, Associate Nursing Program. I'm solving today the ANP National Examinations that was done in the academic year 2023-2024. It's last year's examination. I hope you are going to benefit from these solutions if you are still a student and you are preparing for your examinations, or if you are a teacher, you may get some tips from you how you can help your students to understand these questions and how to answer the questions. If you are a parent, you might have children who can benefit from these solutions, or you might have friends who can benefit from these solutions. Don't hesitate to share with your friends. Tell them that solutions are available for them to follow. But guys, these topics are not restricted to people in Rwanda because mathematics is universal. You can also benefit from this content if you are watching from another country. So keep watching, and if you like the video, don't forget to click like and share the video to your network. If it's your first time to be on this channel, don't forget to subscribe, turn on the notification bell so that you'll get notified anytime we upload a video. Enjoy today's presentation. Write in a comment if you have a question or if you have something to add to my presentation. Write it down in the comment and I will get back to you. So let's move on and start solving our questions. Normally the exam is formed by two sections, section A and section B, and you are supposed to answer all the questions from section A, and you have to choose two questions from section B. You have to choose only not two questions. You have to choose 3 questions from section B and answer all questions from section A. And the exam is intended to be done in 3 hours. So if you are a student, make sure to read the instructions well. That's the first thing. Read instruction well, write your identification well, and make sure that everything is in order, and then start your exam. When you are doing your exam, my advice is to start from the question that seems easier for you. Do those questions that are easy for you, and when you finish, you complete them, you can come back to the questions that seems to be a bit difficult for you. That is my tip. Okay, so let's move on. We are going to start solving the questions right away. Section A. If I have time, I can solve all the questions from section A and section B, but if I don't get time today, I make sure to complete section A, and tomorrow I will make another video, tomorrow or after tomorrow, another video to complete this exam, section B. But if I have time, I will do all the questions right away. So let's go. The first question from section A was this: complete with appropriate word. This is word. This should be word, of course. Complete with appropriate word chosen from the following list: harmonic sequence, constant, geometric sequence, common ratio, common difference, arithmetic sequence. Yeah, this question is intending to know the difference between an arithmetic sequence and a geometric sequence. So make sure that you understand the difference between those two terms, geometric sequence and arithmetic sequence. So in this question, what do we have? Do we have a geometric sequence or an arithmetic sequence? A numerical sequence, Sn. We have a numerical sequence, Sn. I don't know if these characters are big, or let me make it bigger, these things bigger, guys, so that I need the pointer. Maybe this might be small. Let's make the characters a bit big, but this is too big again. It can't fit the screen, so I reduce a little bit, at least this. Yeah. So the question is a numerical sequence Sn. We have a sequence Sn, and such with Sn minus 1 minus Sn equal D. With this relationship is satisfied. With two consecutive terms in this sequence, the difference between two consecutive terms, it is a value D. It is a constant D. And this n is a natural number, of course. It means like a sequence, consecutive numbers. If you take the difference between two consecutive numbers in that sequence, you get a common value. And how do we call this kind of sequence? This kind of sequence is called an arithmetic sequence. So the answer was arithmetic sequence. And how do we call this value D? D is called a common difference. D is called the common difference, and the sequence is called arithmetic sequence. So the answer for this question here, we should have arithmetic sequence. Arithmetic sequence. This is sequence, arithmetic sequence, and D, it should be a common difference. Common difference. Yeah. Common difference. So this was the answer for the first question. The question was intending to know if we know what is an arithmetic sequence, but you should also know what is a geometric sequence. To have a geometric sequence, may I write somewhere? To have a geometric sequence, instead of having, I clean this, wash, yes, for this arithmetic sequence, we have Sn equal to, Sn equal to, we have a sequence Sn, I need to clean this, yes. We have a sequence Sn with Sn minus 1 minus Sn equal to D. One may write it this way, or we may even write Sn minus 1 equal to D. So, yeah, once you may get an expression written like this or an expression written like this. So in this case, you have an arithmetic sequence. But when do we have a geometric sequence, guys? When do we have a geometric sequence? Yeah. When do we have a geometric sequence? To have a geometric sequence, we should have something. We should have Sn such that Sn over Sn equal Sn minus 1 equal D. So if we have a relationship of this form, then this will be what we call a harmonic sequence. And in this case, this D will not be called a common difference. In this case, it will be called common. How do we call it? How do we call this? This will be called common what? Common ratio. This will be called common ratio. Yeah, so that this will be now a harmonic sequence. But in the question, we were not intended to answer for a harmonic sequence. We were intended to answer for arithmetic sequence. So, yeah, now I'm not teaching anyway, so let's move on with the solutions. If you want me to talk more about these topics, write down in the comment and let me know that you want me to elaborate more about this topic. Otherwise, the solution for this question was that one. So let's move on to the second question. The second question was this. Choose the correct answer. Transpose matrix. Transpose matrix is. What is a transpose matrix? What is a transpose matrix? Because this question was intending to see if we know what is a transpose matrix. What is a transpose matrix, guys? What is a transpose matrix? If we have, for instance, I cleaned that line. These tools are disturbing me. These tools are disturbing me, but I'm trying. So don't blame me. Yeah. So if we have, for instance, a matrix, let me take a pen. Yeah. If we have, for instance, a matrix A. Oh, what am I using? If I have a matrix A, which is equal, for instance, 1, 2, and 3, 4. This is matrix A. How do we compute A transpose? The transpose matrix of A. Transpose of matrix of A, it is obtained by changing rows to columns and columns to rows. So we have to take this first row, it should be the first column. So 1, 2. And the second row should be the second column. Then 3, 4. This is the transpose. So we know what is a transpose matrix. So since we know what is a transpose matrix, it is easier for us to choose the right answer from the answers given in the question. Yeah. So, yeah. I'm cleaning this anyway. Okay. So let's choose now the right answer. What is transpose matrix? A matrix obtained by exchanging diagonals. No, we don't exchange diagonals. A matrix obtained by multiplying inverse of determinants to adjoint matrix. No. A matrix obtained by exchanging rows to columns. That's what I've been doing. So the right answer was this one. This was the right answer. A matrix obtained by exchanging rows to columns. A matrix obtained by exchanging rows or columns. No. The right answer was C. Okay, so wasn't it easy? Very easy. Let's then move on. If you have a question, write it down in the comment, then I will come back to you. Question number 3. State whether the following quantities are scalar or vectors. What is a scalar and what is a vector? What is a scalar and what is a vector? A scalar is any measure which is determined by its magnitude. For a scalar, we should have magnitude. Let me type somewhere here. For a scalar, we should have magnitude. A scalar is determined by its magnitude, but a vector is determined by two things. It is determined by magnitude. Am I writing it? Yes, correct. Magnitude and direction. And direction. Yes. So when you are differentiating a scalar to vector, then we are talking about these things. A vector has magnitude and direction, and a scalar has only magnitude. So let's see which ones are vectors and which ones are scalars from the following. A, 10 centimeter cube centimeters of volume. Cube centimeters of volume. Volume. The volume is determined by only its magnitude, and the magnitude here is 10 cube centimeters. Only the magnitude. So since we only have the magnitude, so the volume is a scalar. Then B, acceleration. Acceleration of 15 meters squared per second squared at 60 degrees of horizontals. Here we have two things. We have the magnitude here, 15 meters per second squared, and we also have direction. The direction is at 60 degrees of horizontal. Yes. So we have two things, magnitude and direction. Then this is a vector. Not a scalar, but a vector. Then this was a vector. The answer was vector. Am I typing vector? Yes. And next, C, a downward force of 20 Newton. We have two things here again. We have magnitude and direction. We have 20 newtons. This is the magnitude, and you have the direction. The direction is downward. It's a force that goes downward. Which common force that you know which is oriented downward? Do you know it? Well, write it in the comment, guys. You physicians and mathematicians, of course, you know that force. This farmer's force. How do we call it? Which force? Which force? Okay, so write the force in the in the comment. Okay, let's move on. So what was the force? Is it a scalar or a vector? This is a vector. This is a vector. It has magnitude and it also has direction. Then this is a vector. A vector. And D, a temperature of 36 degrees. Here we have only magnitude. A temperature is characterized by its magnitude. Here, 36 degrees Celsius. Then the temperature is not a vector. Temperature is a scalar. Answers were this one. A volume is a scalar. Acceleration is a vector. Force is a vector. And temperature is a scalar. So you see, questions were easy. Don't worry, you will pass the exam, and your children will pass exam if you are a parent. The exams are not easy. You can even help them to understand the questions so that they will pass the exam easily. So let's move on. Question number 4. Select the best answer. In probability, the incompatible events are. What is incompatible events? I'm not going to go in much details because we need to solve these equations, but you need to know at least what is, let's get to know what is incompatible events. Incompatible events in probability are events that cannot occur at the same time, simultaneously, at the same time. So then choose the right answer from these ones. Are they exhaustive events? Are they certain events? Are they mutually exclusive events or impossible events? So the right answer is the mutually exclusive events, because since they cannot occur at the same time, it means that their intersection will be 0. Then they are mutually exclusive. So the right answer here was these mutually exclusive events. The right answer was C. So you see, if you want me to talk about many things or details and explain all these kind of events, tell me in the comment, write it in the comment. Yeah. So let's move on. Question number 5. So you see, we are already at the 5th questions. The questions are easy, very easy. Question number 5. Find tan minus 1 of square root of 3 over 3. The question is to find tan minus 1 of square root of 3 over 3. Tan, where am I typing? I want to type here. Yes. Tan minus 1. What am I writing? Clean this, yes. Tan minus 1 of square root of 3 over 3. Yeah. This is what the question is. We need to find tan. It's like finding an angle A. We need to find an angle A such that tan of A is equal to square root of 3 over 3. This is the same as finding A such that sine of A over cosine of A equals square root of 3 over 3. Yes. So which angle is this? We need to know at least the standard trigonometric cycle to answer this question. The answer is not just one. There is many angles that satisfy this relation, but that can be an answer to this question. But at least we need to know at least 1 or 2 angles from the standard trigonometric cycle. Do you remember the standard trigonometric cycle, guys? Let me open it. I have saved it somewhere here. This is the standard trigonometric cycle. You need to know at least all these angles and their cosine and their sine. Once you know the cosine and the sine, then you already know the tangent. So if you can look on this trigonometric cycle, you can find that the angles that can give that value of tangent is angles located on this angle here. These angles. So these angles here, and let me take this angle, this, and this one. This one, of course, and this one. This, yes, these 2 angles, and of course this. Yeah, yes. So what are these angles? It's 30 degrees and 210 degrees, and they are connected to a relationship of the form. Let me write it. I close this, but before closing, let me first clean this, and then I close this. So then the answer should be this. The A should be either pi over 6 radians. Is it over 3? Over 6. Pi over 6 radians, or of course 30 degrees. But not only these ones, because in the third quadrant also there are other angles. So then we need to add 180 degrees. Then n times a given value n times 180 degrees. Or in radians, you write it this way: pi over 6 plus n pi. Yes, where n, this n belongs to n. It's a natural number. So that was the answer. You either give this one as an answer, this one, or you give this one as an answer. But I think even if you only tell them that the answer is just pi over 6, or you can just give 30 degrees, they will still give you the points. But in general, the answers are these two, either this or this one. Yeah, so that's it. All right, let's move on. Yeah, next question. Find the limit of x squared plus 1 when x tends to minus 1. This is easy. Don't you see that the answer is 2? Don't you see that the answer is 2? Isn't it 2? Let me clean this. Yeah, so we are asked to find the limit. We are asked to find the limit when x tends to minus 1 of x squared plus 1. So this is equal to minus 1 power 2 and power 2 and plus 1, which is equal to 1 plus 1 equals 2. So the answer is 2. The answer is 2. This was very easy, easy. So the answer was 2. Let's move on. Let's move on to the next question. The next question is question number 7. Question number 7, what does it say? It says complete, let me make it a bit up so that you can see it well. Complete by the degree of the proposed polynomial. How do we know the degree of a proposed polynomial? To know the degree of a polynomial, you should know the variable in the polynomial. In these polynomials, the variable is x. So we need to know the highest power of x in the polynomial. So if you look at this first polynomial, px equal to x power 3 plus 4 power 5 plus x power 4 plus 3 times x, you can see that the highest degree of x is the highest power of x is this 4. This one, x power 4. So then the degree of the whole polynomial is 4. So here the answer is 4. And what about the next polynomial? So if you read the degree, we only have one term that has x. So you read its power. So then we have 10 times x power 3. So the degree here is 3. I mean this one. Let me show you which 3 I'm talking about, because some people may get confused. I'm talking about this one. This one, not this one. Not this one, but this. Yes. So then the power is 3. Okay, let's move on. Then the next polynomial, for this kind of polynomial, you will need to expand it. You need to expand the polynomial, and then you make a polynomial without, you remove these parentheses and simplify with terms that need to be simplified. Then you look at the power, the highest power that is remaining in x terms. So let's go ahead and expand this. We have x minus 1 over 2 power 2 minus x plus 1 power 2. So let's expand it. Our polynomial is x minus 1 over 2 power 2 minus x minus x plus 1 on x minus 1 minus x plus 1 squared minus x plus 1 squared. If we expand this one, this will be equal to x squared minus 2x over 2 and plus 1 over 2 squared. Yes, and then plus this, or not plus, minus, I clean this plus, yes, I clean this plus, then minus, yes, minus x, let me do it this way, minus x squared plus 2x plus 1. So this will be equal to x squared minus 2 and 2 is simplified, then minus x and plus 1 over 4, then minus x squared minus 2x minus 1. So this x squared and this one are simplified to get, then minus x and minus 2x gives minus 3x. And then 1 over 4 minus 1, it gives minus 3 over 4. Yes. So you can see that the term in this the polynomial, the simplified polynomial is only this one, and it has only one term that has x, it's this one, and that term has x with power 1. So then our polynomial is a polynomial of degree 1. So the answer here should be 1. Let me type it there. The answer here is 1. The polynomial has degree, oh, where am I? What am I doing? This was 3. So yes, then here, now here, the polynomial is 1 of degree 1. So that was the answers. Wasn't it easy? Yes. If you feel you want to expand the degrees, go ahead and expand. To expand the polynomial, go ahead and expand, and then you get to know what is the degree for the remaining simplified polynomial. Okay, so that was it. Let's move on to the next question. Question number 8. Without using a calculator, question number 8. Without using a calculator, find the exact value of logarithm of square root of 7 over logarithm of 7 minus 1. So if it's without using a calculator, so we need to use properties of logarithms, and then we simplify. Let me clean this. I wash this. Yes, and clean. So then we need to simplify this logarithm. We have log of square root of 7 over log of 7 power 1. Yes. So if you can see in this expression, we have this the square root of 7. Square root of 7 can be written also in the form as 7 power 1 over 2. Okay? Yes. And the other property that we are going to use in this to simplify this logarithm, we will use the property which says that logarithm of a power b is equal to b times logarithm of a. So we are going to rely on this property. If we rely on this property, then let's go ahead. Then this expression will become, this expression will become, it becomes logarithm of square root of 7, then I write 7 power 1 over 2 over logarithm of 7 power minus 1. And this will be equal to, then if I apply this relationship, I will get 1 over 2, then logarithm of 7 over minus 1 times logarithm of 7. So then the logarithm of 7 is simplified with logarithm of 7, and we remain with 1 over 2 over minus 1, which is equal to minus 1 over 2. So that's the response that we needed. Minus 1 over 2. Just using this, let me highlight it with color red so that you can see it. Yes, we only wanted this. We wanted to know that property logarithm of a power b is equal to b times logarithm of a. Then you apply it, you simplify, then we get t minus 1 over 2. That was the answer. So then let's move on. If you have any question, remember to write the question in the comment and I will answer it. Yeah, so let's move on to the next question. Question number 9. If y equal to 3 times x power 3 minus ln of, the question is here. I write it so that you can know where I am reading from. This is the question. Yes, if y equals 3x power 3 minus ln of 5x plus x, find the second derivative of y with respect to x squared. Yeah, let me use this again. I clean again. Let me clean my board. Clean this. I can even expand this. So I have y equal, I have, oh, what am I doing? I need to, I need a pen, and I need to take a blue color. Yeah, yes. And then we have y equal to 3x power 3 minus ln of 5x plus x. Was it this question? Was the question this one? Let me check it before I mess up. Let's see. 3x power 3 minus ln of 5x plus x, yes. Then we are asked to find the second derivative of y. So let's start by finding the first derivative, dy with respect to dx. We are going to differentiate with respect to dx. So we are going to take the derivative of this one. So the first term here, if we differentiate it, we will get 9x squared. And how do you differentiate the natural logarithm? This will be equal to 5x derivative over 5x. Then plus x derivative. X derivative is equal to 1. This is equal to 9x squared minus 5x derivative. This is minus 5. Minus 5. Then over 5x squared plus 1. Oh, not x squared. Over x. Clean this square. Over x. 5 over x. Yes, 5 over 5x. Then plus 1. Then 5 is simplified by 5. And we remain with 9x squared minus 1 over x plus 1. This is the first derivative. And we are asked to find the second derivative, d squared y with respect to dx squared. So this will be equal to the derivative of this polynomial, of the first derivative, 1 over x plus 1, then derivative of this one. So this will be equal to, this is 18 x, and minus 1 over x derivative is, let me do it so that you can see it where it's minus. Then to differentiate, this is a fraction. Then we have minus x derivative over x squared. Then plus 1 derivative. 1 derivative is 0. This is equal to 18x minus and minus will be plus. Then plus 1 over x squared. That's it. So that was the answer. D squared y with respect to dx squared is equal to 18x plus 1 over x squared. That was the answer. Isn't it easy? Easy. Very easy. Just make sure that you know the properties of derivatives, how to compute derivatives, yeah, of functions. Let's move on. Next question. The next question is question number 10. So you see, we are almost completing the first section. Question number 10. Question number 10 says, if an angle A lies in the third quadrant, we are back on the trigonometric cycle. We are in the third quadrant. You remember where is the third quadrant? The third quadrant. We are in the third quadrant here. We are in this quadrant. In this quadrant, where the sign are negative values, and cosines are also negative values. Whatever you do, remember that the signs are negative and cosines are also negative in this quadrant. So then, since we know, let's go ahead and solve our question. Yes, we have the question says that if the angle A lies in the third quadrant and cosine of A equal minus 1 over 2, find sine of A and tan of A. So let's go ahead and solve this question. I clean this again. Do you guys know how to clean this fast? Let me know in the comment how I can clean this faster than how I can clean this faster. Okay, we have that the question says that cosine of A is equal to minus 1 over 2, and the question is, we are asked that we need to find sine of A. Sine of A equal what? And the tan of A equal what? Yeah. So let's use the famous identity in trigonometry. Guys, there is a video that I made about that identity. I am going to pin it in the comment. Watch that video. This famous identity that says that sine is squared of a given angle A plus cosine squared of that angle is equal to 1. So we are going to rely on this identity and then solve A, sine A and tan A. Okay, so let's go ahead. In this identity, we substitute cosine of A by its value. Then we get sine squared of A plus cosine of A is equal to minus 1 over 2 as this given, then plus minus 1 over 2 squared. This should be equal to 1, which is sine squared of A equals 1 minus 1 over, is it minus? Yes, minus 1 over 4. Because minus 1 over 2 squared is 1 over 4, then minus 1 over 4. This is equal to 4 minus 1 over 4. This is equal to 3 over 4. We have sine squared of a equals 3 over 4. So this implies that sine of a is equal to square root of 3 over 4. Then plus or minus square root of 3 over 4. Remember now the question. The question says that our angle A is in the third quadrant. Since it is in the third quadrant, its sign is negative. Then we will take the negative value. We will take the negative value is, we will take this negative sign and leave the positive sign. And then what are we going to get? We will get that sine of A is equal to what? We will get that sine of A is equal to square root of 3 over 4, which is equal to 1 over 2 square root of 3. Oh, minus. Then minus square root of 3 over 2. That's the sinus value that we are asked for. Sinus of A equal minus 1 over 2 square root of 3. Then let's go ahead and find the tangent. The tangent tan of A then will be equal to sine of A over cosine of A. So this will be equal to, sine is already here, minus square root of 3 over 2, and the cosine. Cosine was given as minus 1 over 2. This one. This. Okay, then this will be equal to 2 and 2 will be simplified. Minus and minus will be plus. Then we remain with square root of 3. That's it. So the answer that they wanted to have, I clean this, and I clean this. So they wanted to have sine. The solution is sine equal minus square root of 3 over 2, and tan of A equal to square root of 3. That's it. That was the solution. Isn't it easy? Easy. It is easy and understandable. So let's move on. If you have a question, write it in the comment. Or if I have made a mistake, write in the comment and let me know that I have made a mistake. Let's move on. Next question. So you see, already 11. Question number 11. We are here. Question number 11. Determine the values of k for which the equation x squared minus x plus 1 over x minus 1 equal to k has no root in R set. Yeah, this is an interesting question. This question is very interesting. So let's try to solve it. Let's try to solve this equation. Anyway, I should clean this. Yeah. Okay. The question, the function is x squared minus x plus 1 over x minus 1. Okay. We have yes. We have x squared minus x plus 1 over x minus 1 equals k. And the question says for which value of k so that this equation has no root, no solution, or no root, no roots in R. That's the question that we need to solve. Let me see if I have written well the question. Yes, x squared minus 1 plus 1 of x minus 1. Yes, the question is well written. Okay, so what we have to do, I need to transform this fractional equation into equation without fractions. Then we can have, this is a k over 1, and do you remember that the product of this is equal to the product of these guys? Yes, you remember it correctly. So then we will have x squared minus x plus 1, this is x, equal to k times x minus 1. And if we remove this side, the second side to the first side, we will get, let me write x in the same way. This is x like this. So then x squared minus x plus 1 minus k times x plus 1, oh, not plus, x minus 1. Yes. X minus 1 then will be equal to 0. Then we can group these terms in x, these ones. How do we group it? We will get x squared minus, let me say plus, then it will be plus x times minus 1 minus k. Yes, this minus 1 from here, this minus 1, and this k. Okay, then minus k, then plus 1, I mean this, and minus k times minus 1 will be plus k, like this. This will be equal to 0. Yeah, so let me rewrite this function so that we can see it well. We have x squared plus minus 1 minus k times x, then plus 1 plus k equal to 0. So guys, which form of equation do we have? We have a quadratic equation of the form ax squared plus bx plus c equal to 0, where in this case a is equal to, is this number here, equal to 1, and b is equal to, so then b is this one, minus 1 minus k, and c is equal to, then this term, 1 plus k. Okay, so what is the condition that has to be, what is the condition that has to be satisfied by this equation? This is x squared. This equation, so that it will not have roots in R, solution in the set of R. The condition is that the discriminant is less than 0. When the discriminant is less than 0, this equation will not have roots in R. The discriminant, do you know how we compute the discriminant for this kind of equation? Discriminant, how do you write the discriminant? Which symbol do you use? I like using delta. Why delta? I don't know. It's just because when I was studying long time ago, we were using delta. But some can use D, or you can use whatever letter you want. The most thing is that you know that it's the discriminant, and the discriminant is given by b squared minus 4ac. This is the discriminant. This is the discriminant. So if this discriminant, if delta is less than 0, then there is no roots in R. Then no roots No solution or no roots. Anyway, you can use any word. No roots in R. Okay, then we have to go ahead and compute the discriminant for this equation. Let me highlight the equation that we are interested in red. It's this equation. This equation. We find its discriminant and then see if and study when the discriminant is negative. May I write up here? Isn't it going to be messy, guys? I don't think so. Okay, let me write here. I'm going to write this side. So the discriminant for this equation will be, I take another color. I've been using blue, let's use the same color. Okay, so the discriminant, the theta in our case, the theta is equal to b squared. B is minus 1 minus k squared. And then minus 4 times a. A is 1 times c. C is 1 plus k. Okay. So this discriminant will be equal to, you can write, it's just, you can say that it's minus 1 plus k squared, like this, to simplify it so that you can see it very well. With these two minus, some of you may get confused, but if I take minus and I put it here, then it will be easier. Everybody will see it. Then minus 4 times 1 is 4. Then 4 times k is then minus 4k, like this. Then this will be equal to 1 power 2 is 1 plus 2k, then plus k squared minus 4 minus 4k. Let's rearrange this expression. Then we will get k squared, I mean this one, and 2k minus 4k, it's minus 2k, and 1 minus 4 is minus 3. Okay, so we are interested in values for which this value is less than 0. When? To know when it's less than 0, we need first to know when this expression will be equal to 0. To know when it is equal to 0, we need to factorize it. We need to solve it. My high school teacher in the second level of high school, a mathematics teacher, Mr. Birusha Prudence, knew well how to factorize this. We used to tell us, we find a number, two numbers whose sum is minus 2 and whose product is minus 3. So those numbers, they are 1 and minus 3. 1 minus 3 is equal minus 2. 1 times minus 3 is minus. So then this can be factorized as k plus 1 times k minus 3 equals, yes, yeah. So then will be equal to 0. When this will be equal to 0, it will be equal to 0 if k is equal to minus 1 or if k is equal to 3. Yes, like that. So then, guys, we need to know when this will be negative, when this will be negative, and when it will be positive. Let's say I'm going, I don't know if you are seeing because my face, my face. Okay, let me write it here. Let me write it here. We take an oriented line here, this line, and if I fix 0 here, then 1, 2, and 3. I have 3 here and minus 1 here. Okay. So, guys, if I take a value in this side of minus 1, this one, let's say minus 2, and replace the value in here, in this, or let's say in this equation, in this expression. If I take minus 2 and replace it here, this will be negative, and this will be also negative. And the negative times the negative, it will be positive. So we will get a positive value. And if we take a value in between minus 1 and minus 3, let's say we take 0, then if we take 0, our expression will be negative, because this k squared is 0 and 2k is 0, then minus 3, which is negative. We have a negative value here. But if we take a value in here, then we will have, if we replace it here, we will have 4, and which is positive and positive. Then we have a positive value here. So the values that we need, they are values that are located to this interval. This interval between minus 3 and minus 1 and 3. Those are the values that can make our discriminant negative. So the answer that we needed, let me clean one space, or I can go a little bit down. Yes. So the answer that we needed was, I take another color, was that minus 1 should be less than k, and k should be less than 3. Or you can write it as this: k should belong in the open interval from minus 1 to 3. Open interval. This was the answer. That's the value of k. Any k that you can take from this interval, our equation, the equation that we had at the top here, this equation will not have a solution in R. Yes, so that's it. You have a question? I don't know. Write it in the comment, or if I have done something wrong, then write it in the comment and let me know. Let's move on. That's it, what I have to say to this question. So let's move on. The next equation, question number 12. Question number 12. It says 200, this is the question, 200 milligram of a medication is administered to a patient. After 3 hours, only 100 grams remain in the patient's body. Using an exponential decay model, find the hourly rate of the medication decay. Okay, so there is a patient, and the patient received a medication of size 200 milligram, and after 3 hours, they went to inspect his or her body. Then they find that he was only having 100 milligram of that medication remaining in his or in her body. So they want to know how the medication is meriting or decaying inside the body. So that rate. And they want us to use the exponential decay model. The key here is to know what is exponential decay model. The exponential decay model is a model of the form. Do I need to clean this one, or I can just take a new, okay, let me clean this, or I can take a new page. Yes, I take a new page. Okay, so what is an exponential decay model? Exponential decay model is any model of the form nt equals n0 e power minus kt. what is nt, what is n0, what is k, and what is t. T is time. T is the time. This is time. In this question, then it is hours. In the settings of our question, it is hours. And the NT is the amount. This is amount at time t. And N0, what is N0? N0 is the initial amount. The amount we start with. Initial amount, yes. And what is K? Then K, this is the decay rate. The question which is asked, decay. This is the decay rate. And T is time, of course. So in the settings of our question, we have T is equal to 3 hours. This is 3 hours. And NT, after 3 hours, we have 100 milligram remaining in the body. So NT is 100. And the initial amount was 200. This is 200. So we need K. How much is K? Now the question is set up and we can go ahead and solve for K. We replace each value in this expression, then we find K. So let's go ahead and replace. So we have, what do we have? We have 100 equal to N0, then 200 e power minus kt. Then t is 3, then minus 3 k. Then we need to solve for k. How do we solve this equation? We have 100 over 200 will be equal to e power minus 3k. 100 over 200 is equal to 1 over 2. Then 1 over 2 equal to e power minus 3k. So if we apply natural logarithm both sides, ln natural logarithm both sides, if I apply ln both sides, what do I get, guys? I will get ln of, this will give me, let me take this a little bit up, yes. So this will give me ln of 1 over 2 equals ln of e power minus 3k, this is equal to minus 3k. I'm applying the same properties that were applied in the previous equation. So then k will be equal to, from this equation, k will be equal to what? K will be equal to minus 1 over 3 times the ln of 1 over 2. So if you have a calculator, you go ahead and compute ln of 1 over 2 or ln of 0.5. And if I remember well, this will be equal to 1 of minus 1 over 3, and ln of 0.5 is something minus 0.6931 and so on. So this kind. And then k will be approximately equal to 0.23. Yeah, this you can calculate it with a calculator. This I used to know it in my mind, but you can calculate it with a computer. So this k, this is a value that we were asked for. K approximately equal to 0.23, and you can maybe write that the medication is decaying. The medication decays 0.23 per hour. Yes, That's it. That was it. Wasn't it easy? Exponential decay model. Do you know it now? If you didn't know it, that's the model, and that's how it works, and you can see that it's a very useful model. So let's move on to the next question. So the first section is almost done. In how many minutes? Because the exam, if you are doing an exam, but of course in the exam you are not explaining to anybody, so you are just writing what you know. You can't take much time as me, but even me, you can see that we will not use so much time. So let's move on. Question number 13. Given the polynomial pz equal to, let me write it down somewhere so that I will not forget it. Equal to, we have pz equal to z power 3 minus 6z squared plus 13z minus 10. Okay, this is the polynomial. And we are asked to factorize polynomial and then solve pz equal to 0. We first have to factorize, then after factorizing, we solve for, we solve for pz equal to 0. Yeah, let's go ahead. We have pz, we have our polynomial is pz equals z power 3 minus 6z squared plus 13z and minus 10. Yes, minus 10. We need to factorize it. How do we factorize this one? How do you factorize this one? One method, there is many methods, but one method that we can use here is the rational root method theorem. Rational root theorem, we need to find the roots based on this independent term minus 10. We find all the numbers that can divide minus 10, then we substitute it in pz to find which one will give 0. So the numbers that can divide that minus 10 is plus or minus 1 and the plus or minus 2 and plus or minus 5 and plus or minus 10. So we can just go through these numbers starting from the small one to the big one, and then we replace it in this pz and see which one will give pz equal to 0. If the value give pz equal to 0, that will be the root, the first root. So let's start with, let's take z equal to, let's say 1. If we take z equal to 1, we will have pz will be equal to then 1 power 3 minus 6 times 1 power 2 plus 13 times 1 and minus 10. Is this equal to 0? I don't think so. This is equal to 1 minus 6. 1 minus 6 is minus 5. Minus 5. And this is 13. 13 minus 10 is 3. Then plus 3. And then this is equal to minus 2. Minus 2, which is different from 0. What if we take z equal minus 1? If z equal to minus 1, here we will have, instead of having 1 here, because 1 minus 1 power 3, it will be minus 1. And here we will have, okay, we will have, okay, let me write it. Pz equal minus 1 minus 6 minus 13 minus minus 10. So this is also different from 0. Okay, what if we take z equal to 2? Z equal to 2, pz will be equal to 2 power 3 minus 6 times 2 power 2 plus 13 times 2 and minus 10. So this will be equals to 2 power 3, it's 8, minus 4 times 6 minus 24. Then 13 times 2 is 26, and minus 10. Okay, 24 and 26, this will give us 2, and 10 and 8 will give us minus 2. Then 2 minus 2 will be equal to 0. Okay, we finally get one root. That's good, fast. We get one root. So since pz is equal to 0 when z is equal to 2, this implies that z minus 2 is a factor of our polynomial. This z minus 2 is a factor of our polynomial. So it means z minus 2 times another polynomial will be equal to pz. And which will be this other polynomial? This other polynomial, since our initial polynomial, I mean this pz, since this polynomial pz is a third degree polynomial, and we already have this one in 1 degree, so this will be a second degree polynomial. Second degree polynomial. So we need to find this second degree polynomial. How do we find this second degree polynomial? We will take pz and we divide it by z minus 2. Do you remember how to divide the polynomials? Do you remember? Do you? It has been a long time without I divide, but hopefully I remember. Then how do we divide this? We first have, and I will use this. We need to know the coefficients of our polynomial. Yes, the coefficients. The first coefficient was this value here, 1. The first coefficient is 1, and the second coefficient is minus 6. The third coefficient is 13, and the other one is minus 10. Okay, we have the coefficients, and we are dividing by z minus 2. If we are dividing z by z minus 2, it means that the root is 2, and you write the root here. What do I have? Yes. Then you write the root here. The root is 2. Then we have 1 here, and we multiply. 1 times 2 is equal to 2. Then minus 6 plus 2 is equal to minus 4. Minus 4 times, this minus 4 times this 2 will be equal to minus 8. Then then 13 minus 8 is equal to 5. Then this 5 times this 2 will be equal to 10. And 10 minus 10 is equal to 0. Okay. Then what do we get? We will get a polynomial z squared, because the coefficient here is 1. And the next coefficient is minus 4. Then minus 4z, and the independent term will be 5 plus 5. So which means that our polynomial is factorized as, then we have pz equal z minus 2, this z minus 2 times this one, times z squared minus 4z plus 5. Good. That's A. That's our A solution. Factorize. Now we have already factorized our polynomial. This was A factorized. What is B is asking? B, we are asked to solve for pz equal to 0. Do you allow me to take another page, guys? Because this is not going down, and I think like this you are not seeing it well. Let me take another page here. So we have already factorized, and we have find the factors as pz equal to z minus 2 times z squared minus 4z plus 5. This is the factors that we have just seen. So after factorizing, we are asked to solve for pz equals 0. Pz is equal to 0 if and only if z minus 2 times z squared minus 4z plus 5 is equal to 0. And this holds only if z minus 2 is equal to 0, or if z squared minus 4z plus 5 is equal to 0. And we have z equal to 2, or how do we solve a quadratic equation? Do you remember how to solve a quadratic equation, please? If you have equation of the form ax squared plus bx plus c equal to 0, how do you solve this equation? This equation is solved by x equals minus b plus or minus square root of discriminant over 2a. And you remember how to find the discriminant. The discriminant equal to b squared minus 4ac. If you don't remember, the formula is this one. So if we apply this to this equation, then z will be equal to, this is minus b. Minus b is in this case minus 4. Then minus 4 is plus 4. Yes. Then minus or plus or minus square root of b squared. B squared, b is minus 4. Minus 4 squared is 16. Minus 4a, a is 1 times 5. The square root here. Over 2a, over 2. A is 1, like this. So our equation, our polynomial is equal to 0 if and only if z is equal to 2. I clean this. Yes. Yes, our polynomial pz is equal to 0 if z is equal to 2, or if z is equal to, so if we sum up all this expression, we will get 4 plus or minus square root of 16 minus 4 times 5 is 20. 16 minus 20 is minus 4. Square root of minus 4. Then over 2. And square root of minus 4 is equal to what? Is equal to 2i, because we are solving in the set of complex numbers. So then we have 4 plus or minus 2i over 2. Then we simplify. 2 and 2 and 4. Then here we have 2 to have z equal to 2 plus or minus I. Okay, all right. Then we have our solution. Set of solutions will be, in this case, these 2 and 2 plus I and 2 minus I. So these are the solutions. That's it. That's it. We have already solved it in the set of complex numbers. And this is the set of solutions that we obtained. Isn't it easy? Is it difficult? I don't know. Write it in the comment and let me know if I am doing well or bad. Yes. So that's the solutions. Let's move on to the next question. Next question, question number 14. Question number 14. Calculate the relative asymptotes on the curve of the function we have f of x equal, and then equal 4x plus 1 over 2x minus 6, and sketch them on Cartesian plane. Okay, all right. So we have this 4x plus 1 over 2x minus 6. Okay. I take another page. Yeah. We have our function f of x equal to 4x plus 1 over 2x minus 6. This is the function that we have, and we are asked to find asymptotes to this equation, to this function, and then sketch those asymptotes in the Cartesian plane. Do you remember how to find asymptotes? How many asymptotes exist? There is vertical asymptote, horizontal asymptote, and oblique asymptote. For any question, any function, the horizontal asymptote and the oblique asymptote cannot exist at the same time. If one exists, the other one doesn't exist. But when do we have a vertical asymptote, and when do we have a horizontal asymptote? When do we have a oblique asymptote? Let me start for oblique asymptote. The oblique asymptote exists. When does it exist? It exists if and only if the degree in the denominator, if the degree in the denominator, the denominator is 1 plus the degree in the denominator. Oh, this one. Let me clean this one. This if the degree in the numerator if the degree in the numerator n, if the degree in this numerator is 1 plus the degree in the denominator, then in that case we will have oblique asymptote. For this function, this particular function, we will not have oblique asymptote because the degrees are the same degrees. So we will have an oblique, a horizontal asymptote and a vertical asymptote, if exists, of course. So how do we find a horizontal asymptote? How do we find the horizontal asymptote? The horizontal asymptote is such that the limit, it's the limit when x tends to positive infinity and negative infinity, plus or minus infinity of our function x. So any line of equation y equal this limit, this will be the horizontal asymptote. So let's go ahead and find then this limit. So this limit will be equal to limit x tend to plus or minus infinity of 4x plus 1 over 2x minus 6. And this limit, because we have the polynomials of the same degree, so it will be the coefficients of these values in x. So it will be quotient of this and this. So then will be equal to 4 over 2. This will be equal to 2, which implies that we have a horizontal asymptote of equation y equals to 2. This is the horizontal asymptote. So then how do we find vertical asymptote? The vertical asymptote is obtained by solving the denominator to be equal to 0. Is obtained when the denominator is equal to 0. When this is equal to 0, then we get the vertical asymptote. So then to find the vertical asymptote, we need to solve we need to solve denominator, then 2x minus 6 equals to 0. If we solve this equation, we will get x equal to 6 over 2 equals to 3. So then the vertical asymptote is of equation x equal to 3. So these are the two asymptotes that we will have for that kind of function. And we have been asked to sketch these asymptotes in Cartesian plane. What is a Cartesian plane? What is a Cartesian plane? Write in the comment, what is a Cartesian plane? Yeah, so let's sketch it in a Cartesian plane, a plane of two axes. We have, I don't know, please use a ruler when you are sketching this because my lines are not perpendicular. We'll make them perpendicular because this is the axis x of coordinate, axis of x coordinates, and axis, this is axis of y coordinates. Make them perpendicular, use a ruler. So here we have 0, this is the origin, 0. Then we have to sketch these two lines. This y equal to 2 and x equal to 3. Let's start with x equal, this is 1, then 2, then 3. If I have 3 here, this is 1 and 2, so then 3. Then we have our vertical asymptote at this point. X equal to 2, this is equation x equal to 3. And the horizontal axis we pass at x, y equal to 2. We have 2 here, 1. So then we have a horizontal line here. This y equal to 2. Please make sure that your lines are very well sketched, the perpendicular, not this with this like mine. Use a ruler. Yeah, so that was the question. I don't have anything to add. We were not asked to sketch the function. We were asked to sketch only the asymptotes. So then the asymptotes are those ones. I'm not sketching the function. If you want, you can sketch the function, but don't waste your time if you are not asked to. Just do what you are asked to do. Yeah, so let's move on. Next question. And the last equation in section A, 15th question. Here, this question, solve dy over dx equal 1 over x squared plus 2x. This is a differential equation. How do you solve this kind of differential equation? This is a separable differential equation, and how do you solve it? Solve this differential equation. The differential equation that we are asked to solve is dy over dx equals 1 over x squared minus, is it minus or is it plus? Maybe plus plus x plus 2. I don't know. Let me check before I mess up. It's 1 over x plus 2x plus 2. 1 over x squared plus 2x plus 2. So this kind of differential equation is called the separable differential equation. Then how do we solve this kind of equation? We just separate x's and y's. Then we will have dy equals 1 over x squared plus 2x plus 2 dx. And then you integrate both sides. We integrate both sides. If we integrate the first one, we will have y. And this will be equal to integral of 1 over. Let me change this into this kind of this 1 plus x plus 1 squared and plus what? If I take x plus 1 squared, this will be x squared plus 2x plus 1. But here we have plus 2, so then we have to add another 1. So this and plus 1. So then we have plus 1 here. Let me clean this. Yes. Okay, so I have transformed this into this common known differential equation, this form. Everybody needs to know this kind of differential equation. How do we integrate this? We can integrate it by substituting this value by, we can write x plus 1 equal to u. If we write x plus 1 equal to u, then we will get dx equal to du. And then we go ahead and substitute these values into here. If we substitute this into that one, we will get y equal to integral of 1 over u squared plus 1 and du. How do you integrate this one? Everybody have to know it. This is tan minus 1 or arctan. Tan minus 1 of u plus a constant. When we are given some initial conditions, we can find the value of this constant. But since we don't have initial conditions, then we don't need to solve for that constant. The constant is there. But we have to go back, of course, and replace the value of u by its value here. Then we get y equal to tan minus 1 of x plus 1 and plus c. And this is the solution. Isn't it easy? Yes, it is easy. And hula! This is the last equation in section A. So once you are done with section A, you have to choose 3 questions from the second section.